Hello everyone, welcome back to our Generative AI and Agentic AI series. In the last video, we understood about the RAG concepts and now we are going to implement the RAG concepts. So, we'll be going to implement a project. With the help of that project, we'll understood how we can implement the RAG concepts. So, this project is an AI powered resume analyzer, and that will extract resume content from the PDF or docs files, and it will use the Gemini LLM models to generate resume score, eligible job roles and improvement suggestions for us. And to make the analysis more accurate and company specific, we are going to implement a RAG concept here. RAG means Retrieval-Augmented Generation. So we are using the RAG concepts to get the company specific data. And now we'll be using here the ChromaDB, that is the vectorless DB, or sorry, that is a vector DB. Now we'll have some ATS rules, resume guidelines and job requirements that will be stored in the DB. And when a resume is going to be uploaded, the system retrieves that relevant knowledge from the vector database and provide a context-aware resume evaluation instead of relying on that LLM general knowledge. So LLM is trained on the general knowledge, as we already learned about it. So now if we'll provide some company specific data, so that will be more context, right? So on the basis of particular company, it will go and analyze our resumes. So we'll talk about the overall architecture here, what we are going to implement. So we'll have user or client, and it will call a post endpoint, that is upload resume, or it will have one resume file, it will upload and hit this endpoint. It will go to the fast API service. What it will do is, this service will do, this will extract that test file and it will send to the text extractor. Now our resume file is extracted and text extractor will send that resume plain text. Now what are the data is there from the file, that is a plain text, and again it came back to the service. Now service will go for the similarity search from the, what are the plain text we got from that, it will go for the similarity search and it will go to the vector DB where we already stored our data. Okay, and it will generate the embeddings and it will have some vector search, means in DB also we have to make the search, so we'll have vector search and metadata retrieval. From here it will go and retrieve the metadata. Okay, and when we'll come from this vector DB, we have relevant context chunks, so we'll not just get only one record, we'll have 3 or 4 records, top k elements will be there. Okay, and then it will, that now service layer will be analyzing it and it will create the context, what are the contexts we have provided and what are the contexts came from the vector DB. It will combine these context and our context and vector DB response, and it will send to the LLM analysis engine, and this will analyze that candidate, means our resume content with vector DB content. It will analyze it and it will processing that data. It will process here LLM analysis engine, it will process that data and at the end it will return the JSON response back to us. And now in this JSON response we will have that data, what are, we'll give the prompts according to that, what kind of JSON response we want, that data will be getting it and it will be sending back to the users, and user will get the 200 response with full analysis report. We have that report with us, so that is the response we'll be getting it here. So this is a high level architecture, and when we'll be implementing it, at that point of time maybe 1 or 2 extra fields or content files will be added. So we'll have one app folder, this is the main folder. With inside that one we have APIs, core where configurations file will be there, then services, so we'll have resume service, LLM service, RAG concepts is there, utils is there, and knowledge base. We have to create a knowledge base. Why? Because we don't have any DB, or we don't have, not DB, we are going to implement the DB, but we don't have any knowledge base, so we don't have any documents, wiki pages, or any database where all the data is stored. So what we are doing is, first we'll create few static files where we'll mention few rules and regulations to analyze the resume. So we'll have knowledge base here. Then inside that itself we have main.py, and when we'll have knowledge base and we'll parse that data, we'll get the ChromaDB. So we'll have one DB. These are the environment requirement files. So now we'll go to the IDE and we'll see how we can implement it. So first we'll understand what are the basic setups we needed to run this RAG based application. Then we'll write the code changes or endpoint to get the RAG plus LLM based responses. Okay. So first thing we need it, if we'll go here, we need this config file. Okay, so we'll have configurations over here. So what this line will do, it will go and load the environment variables from the .env file. If you remember from the LLM video, I mentioned it in the .env file, we are going to store the Gemini API key. So that is the secret key for us, so we cannot reveal it to anyone. So I stored my key here over here in the .env file. Same way you can go and save it your env file here. So what it will do, it will go this part load.env, it will go and load environment variable from a .env file. Then we'll have Gemini API key in the environment variable file. It will fetch that, it will fetch or read the Gemini API key from the environment variable. And we have settings. This will be the instantiating the setting objects. So this module is only centralized for the configurations for the Gemini API key. Now we'll move to the, this is inside the core folder. Now we'll move to the another one. These are the basic setups which we need to implement our endpoint. So now we'll go to the knowledge base folder. As I already mentioned it, we do not have any DB or wiki pages. That's why we are creating these txt files. So I created one ATS rule.txt file where inside that I included few ATS resume rules, just like as include relevant keywords, avoid tables and images, use standard sections headings, qualify in achievements, include measurable impacts. So this is the rule I set for the ATS rule. And then we'll have Java backend requirement. So here I just mentioned few things, but we can include few more. Okay, so we have microservices in which we need REST API, SQL, then preferred Kafka, Docker, AWS. These things are the preferred ones. Then resume guidelines. Resume guidelines are use action verbs, highlight business impact, keep bullet points concise, add project outcomes. Okay, so it will just go and read these things. And then software engineer expectations. What are the expectations from the software engineer? They have some strong coding skills, system design knowledge, problem solving, communication skills. And these files are like, it depends on company to company, which company want what kind of rules and regulations for their positions, right? For every position they have some different rules and regulations. So here we have to decide, okay, what kind of rules and regulations we are going to use. Okay, so that's how we can modify these files. Or usually companies will use their database and their pages where they updated all these kind of things. Okay, so this is, we created a small knowledge base using a few sample files here. So in a real world, what companies will do, they have few environments, okay, and their knowledge bases will be just like as large volume of data from the multiple sources, just like as wiki pages, database, PDFs, documents, or any other internal systems as well, internal sources as well. Since we do not have access to such kind of enterprise database for this project, so what we did is we just created this knowledge base folder and will be containing few sample files over here. And now to simulate our knowledge base, so what we'll do is, now we'll go for the vector store. Okay, so if we'll go in, okay, let me close everything. Then now we have a knowledge base. Now we need to create, now we have to store that data. we created knowledge base and we have few files, and now that files we need to create in the DB. So for that we are going to use the ChromaDB, and we have to go inside this rack, and we have this vectorstore.py file. So it will create or connect to the ChromaDB collections, and this will create a persistent ChromaDB client at the ChromaDB. Okay, this will create the persistent client at the ChromaDB. And now get or create, what it will do is it will go and create a resume knowledge base collection in the DB. In the DB, we will have one resume knowledge base now, and this collection will store document text, what are the documents is there, that text will be there, and it will generate the embedding also. It will generate the embedding for us using the Gemini models. We use the Gemini model, so it will use the Gemini models, and it will have metadata just such as our source file as well. So this modules just hold the persistent vector collection used by the retrievals. Okay, now we'll go for the ingestion. Now we have ChromaDB, we have one DB, we have knowledge base, we have vector store, means where we have DB name, and now we have to do the ingestion. Okay, so for this what we are going to do is it will, now we mention the knowledge base path here. Okay, so if you'll see here, we created this knowledge base inside the app and knowledge base, so it will know about the knowledge base now. Okay, so here we just printed it out. Okay, our knowledge base exists or not. Okay, and then we'll go for the for loop. So it will, what it will do is it will iterate all the txt files under app knowledge base. So we have 4 files. It will go and iterate one by one file in the inside the knowledge base, and it will generate all the embeddings here. If we'll see, okay, vector store is done. Let me close few extra files, so will be in a sync. Okay, so what it will do is this one. Okay, we are using the UTF-8. This will read the text from the files. Okay, if there is no content inside that file, suppose if we inside this ATS rule, nothing will be there, it's just an empty file. What it will do, it will continue, it will skip that empty file, and now it will go to the another file, and then it will read it. If that new file is exist, if that is done, will come out from the loop. Now embedding, here we are going to generate the embedding. Okay, so we go to the embedding services. Okay, why we need embedding now? Because we have ATS rule, or we have a knowledge base. Here we created it as a static knowledge base, but suppose from tomorrow onwards, if we'll be getting that dynamic knowledge as well, but still we have to store, or we have to embed that data to the DB. So we cannot embed that data as the form of text, so we have to do the embedding. So for that we are using the embedding service here. So we'll get that string, we'll get that data from the ingest.py file. What are the content is in the text files, will be getting it over here, and this is just a print statement. And for embedding we are using the Gemini embedding 2 models, and will be setting this text, what are the content will be getting from the text files, we'll be setting it over here as the content, and we'll be using the Gemini embedding 2. Okay, and this one we have to set that Gemini API key inside the .env file. So Gemini API key we have to set it here, and this will be going to use the Gemini embedding 2 models. Okay, so this will return the some numeric embedding vector from the responses. Okay, so what it will do is this one convert the, now we have some text, right? So when we'll do the embedding, so what this service will return is, this service convert any text into a dense vector for a similarity search. Okay, and now if this will be done, when we'll come back here. Okay, so now we have embedding data, embedded data we'll have. Now in the, now what we'll do is we'll add the metadata to the vectors store with a numeric ID. Now what are the metadata is there and text is there, that will be stored in the DB with a numerical IDs will be there. And this is the source file, means our source file name like ATS rule and Java backend requirement, these will be also stored in the metadata. Okay, so now this knowledge base, we have loaded our data into the knowledge base successfully. So we'll get these, and how many documents we loaded it, all these counts will be getting it here. So what command we need to run to ingest that data into our DB? So for that we need to use the, one second, okay, so we are inside the VENV folder, we have to be in the virtual environment. So oh, sorry, that's my bad. Yeah, so we already have this Chroma, where it went again, yeah, ChromaDB. So there will be not much difference, we'll see it here. But if we'll suppose I'll delete this folder, okay, you'll see, right, it documents available for knowledge base exists true, ATS rule, these things will be there. Now if I'll remove this ChromaDB and I'll run this command, yeah, so initially we have 0 documents in the knowledge base, and you'll see here we got the one ChromaDB folder again back. Okay, so knowledge base exists true because that is already there, but we cannot see here. So processing, we will be processing ATS rule, it generated the embedding, added ATS rule.txt, then it will process the another document. So one by one it will go and processed, and at the end we have document count as 4. So if we'll see, we have just these 4 documents with us. So like this we can create the, we'll do the ingestion for to store the data in the vector DB. Now what this script did, this script is used for offline. Offline means, it doesn't mean we are not we don't have any documents in our system to store it. Offline means before we'll be going to run that endpoint, before that we stored that data into the DB. So that's why this is offline for us. So this script is used offline to populate the ChromaDB knowledge base from static. We are using these static files, right? That's why I'm mentioning here that static.txt documents. So now these are the basic things which we have to do before starting to create our endpoint. Now we'll go and create the endpoint. So our endpoint is, okay, before that we'll go for the main.py file. So in the main.py file we have app fast API, title is AI resume analyzer, debug equal to true. So it will create the fast API app instance for us, okay, with some metadata. We mentioned a debug here, so if we'll get any issues, we can see the, we can trace back all the logs there. So that's why we made it here as a debug is true. Then this, what this part will do is app include router resume.router. So this will register the routers, what are the endpoint I mentioned, right? These are the routers here, so it will route that to the application. Okay, this file does not itself start the web server. This is a practice that server is run with a command like, we means this will not start our web server. So for that we have to use the command uvcorn app dot main app reload command. So we'll see that command as well. Now we'll move to the resume.py from where our router will start. Okay, so from here we have router equal to API router. What this means is, this will create a router object for endpoint registration. So we have these endpoints, maybe in future we will have more endpoints, so it will help us to create the router for our endpoint. And if you'll see, this is the post endpoint. We have one post endpoint, resume analyzer. Why this is a post endpoint? Because we are going to upload our resume in this endpoint. When we'll upload our resume, at that, when we'll hit the endpoint, then we'll get the response whether that whether we are up to mark for that particular position or particular company or not. Okay, so this is a method. It will go and analyze the resume, and here we'll get our file, whether that is a PDF or docs. So for now we just implemented two format, that is one is PDF and docs. So most of us will be writing our resume in PDF or docs format. So we'll get our resume here, and it will go for the process resume. He will send the input as the file. What are the file will be getting, will be sending it to the here. So we'll have resume service now. Okay, so here we got that file as an input. We have now PDF file. So first what we have to do is we have to extract the data. So we have a full file. Okay, so we have to extract that text from the file. So we are going to pass the file again to the another method, that is extract text from the file. Okay, so what it will do, what this will do, will have now file. Okay, so it will check whether that file is ending with the .pdf or .docs. If it will be ending with the .pdf, it will go for the PDF extraction. Okay, so in the PDF extraction, so here what it did is this selected the correct parser in which file we have to go and parse our data. So it just selected the which is the correct parser based on our file extension, like as PDF or docs. Okay, now if we'll have in the PDF parser, so what it will do is extract PDF. So here it will go and extract the PDF from, we have one PDF file, it will convert that PDF file to the text. So now we have text details from the PDF parser. Then extract docs, it will extract that docs. So there will be a paragraph, it will iterate the paragraph and join it and make that as a text. So now we have the text file converted to the, sorry, that PDF or docs file is getting converted to the text. So now we have one text in place of file. Now we have a text. Now we'll go to the next step. So here we are just printing, so we'll get to know that till here we came successfully. So resume extracted successfully. Now we have second step, we have to retrieve the context. Okay, so what we are going to do is we are passing our text, whatever the text we are getting from the file, we will be passing it to the retrieve context method. So in this method, what it will do is it will go and fetch related documents from the knowledge base. So if we'll go inside this method, we'll see here is retrieving context. So it is going to retrieve the context, and this is first thing is it will be going to generate an embedding for the query text. So we are going to send this query, what are the text we converted before from here. If you'll see, we are getting this input, right? So this input or this text we are sending to the generate embedding. So what it will do is here again, last time when I showed, when we'll be storing the data into the DB, at that point of time as well, we used same embedding model. So again we are going to use the same embedding model for the embed our text. Okay, so here we are using the Gemini embedding 2 model, and it will take the text and embed that data, and we'll get that data, embedded data here. Okay, so query embedding is done. Now we are going to query the ChromaDB collection for the top 3 nearest documents. So we want top k documents. Top k here is 3. We just want top 3 document here. So we passed our query embedding and we asked for top 3 documents. So it will go and query for the top 3 nearest documents. So we have to match whatever the query is there and whatever the data is stored in the vector DB, both will be matched, and whatever the top 3 elements will be there, will be getting it back. Sorry, top 3 documents will be getting back. And when we'll have that, so this part is done. So querying from the knowledge base is done. Now we have to store that into the metadata. So what it will do is, when we queried it and now we join the retrieved document into a one text blob separated by the new lines, okay, separated by double new lines. So we have to get all that data, and then so we have to join that data. So we have data items in the metadata, we'll iterate it. If our item is none, we have to continue. If item is there or data is there that is not none, we'll get the source file. Source file means these file names, knowledge base file names, okay, these are the source files for us, and it will append that data, and it will join all that data into the retrieve context variable, and it will be separated by the new lines every time. Now we have all the sources, top 3 sources from the vector DB. So we retrieve that context and store that. If you'll see here, we are returning the retrieve context and source file. So we are going to return what are the data we got from the knowledge base and the source files names, means from maybe ATS rules we'll got it, or from some Java backend requirement. So we are going to return that data. This is the work of the retriever. So retriever context and source from the RAG result dictionary, we are returning it back. Okay, we'll come back to the resume service. Now we retrieve the context or data from the DB. Now we are going to the next steps. So this is the context and the source files we are storing in one of the variables. Now we have to call the Gemini model, means we are going to call the LLM services now, because we have text from the DB also, and we have the data, we have our context and DB data. So now we are calling the LLM models here. So here we have to pass the text. What are the text is there, means our text, our PDF file text, and then we have whatever the data we retrieved from the DB, both we have to pass here. Before we will be just passing the text, because we don't have any DB and we are not retrieving the data, but now we are retrieving it, so we have to send this data to the LLM. Now if we'll go inside this is analyze resume with LLM. So here we are creating the Gemini API client. Okay, so here client will create, and now we'll have that text and retrieve context. So we wrote a prompt. Okay, we have a prompt that will instruct the model how it can act as a career consultant. It will embed the retrieve context and the resume text into the prompt, and we'll get the strict JSON schema. Okay, so that's what we mentioned here. Let me put it down. Yeah, so if you'll see, it mentioned you are an expert career consultant, so use the retrieve context while evaluating the resume. Retrieved context, so what are the context we retrieve, we'll provide that context, then resume text, okay, we'll provide that text, and it will return only a valid JSON here. So we mention the format, in what format you have to return. So you have mentioned score, then eligible roles, improvements, and then after the structured resume, what is the name, skills, experience, and education. These things will be written from this prompt. Okay, so we mentioned it, what kind of JSON response we need it here. Okay, now if we'll see here, we'll be using the Gemini 2.5 flash. Okay, so we'll be sending this prompt and we'll be calling Gemini 2.5 flash. Okay, model will be calling it here. So it will go to this prompt, and it will go to this model, and it will provide us the response here. And when we'll have the response, what we are doing is we are removing some markdown style codes. So what it's, if it's present, if we'll have JSON or this kind of symbols, we'll be just removing it over here. Okay, so we are just doing some cleanup of the data. Now we have that response from the LLM. Okay, so here the exception part is there. Okay, so So if some failure will be there, it will print that, and debug information will be there in the console. We can see it, okay, and it will re-raise the error. So this module is responsible for final resume analysis and output formatting for us, okay, and it will return a dictionary which will contain analysis, RAG resources, retrieved context as well, okay. And this, so now from the LLM service, we'll come back here, and this is analysis is completed, and it will return the analysis, RAG resources, retrieved context will be there. So analysis means we'll have LLM results. RAG resources means list of source file names from the vector DB. Okay, what are the vector DB data is there? Means in name of ATS rule, Java, resume, these things will be there in the RAG resources. Then retrieved context means that assembled text from the matched document, so we'll be getting it here, okay. And this is the, okay, if we'll go back, so this is the function, is the, this is a central controller for the request life cycle, okay. So from here that request is started, it went and came back to this part again. Here we'll get the success or failure results will be there, okay. So we'll go back to our PPT, just 1 minute. Yeah, yes, so we have to run these two command, python -m app rag ingest, which we already saw, and now we have to run this command, uvcon command, okay. This will help us to run our service. 1 second. Yes, we'll run this command and we'll see what will get the output, whatever we implemented till now, what is the response we are going to get it, okay. That is correct or not, we'll just check it. So now we'll go to the, now we'll hit the endpoint, okay. This is the endpoint. When we'll hit it, we'll get the resume analyzer post endpoint. Now we'll try it out and we'll just choose one resume, okay. We'll execute it. It will take few seconds and then we'll get the response, okay. So now there is some internal server error, okay. What is this one? This model experiencing high demand, the spikes in demand are usually, okay. So what are the model we are using? It has high demand, that's why it's taking more time. Let's just try it one more time. I hope this time it will free. Okay, yeah. So we got the response. So as we discussed, we have a status, that is success, and then data is score, overall, skills, experience, okay, education level 1, eligibility role, okay. So for web UI designer, confidence is 0.9. The reason, the resume explicitly state web UI designer and list primary skills in Adobe Photoshop, Illustrator, XD, and Flask, which are core tools for web and UI design roles, okay. So anything for backend developer, confidence is 0, because they are the web and UI designer, and everything we are checking from the backend role. So it suggested the improvement, tailor your resume to targeted role. The current resume is explicitly for a web UI designer, okay, but you have to, if you'll go, and is completely unsuitable for a backend developer. See, we already know you are the UI developer, but you want some backend developer job, so you have something in your resume regarding the backend development. So that's what improvement it mentioned it here. And then it mentioned the name, skills, whatever you have, experience is nothing, then education, degree, and at the end it uses top three, that is resume guidelines, ATS rule, and Java backend requirement. Top three text files it used here, and it retrieve the context, resume guidelines, use action verb. So whatever we mentioned it here, it just got it, okay. So now we understood how we can implement this one, and these two commands we need it when we want to ingest the data into the ChromaDB. Suppose if we have to insert few new files or we have to update that files, we need to use this command. So this command we need it when we want to update or insert any new document in our DB. So for this, for running our application, we need the uvcon app.main command. So this command we have to use every time when we want to hit the endpoint or when we want to use this Swagger UI to check our resumes. We need to hit this endpoint, sorry, this command. And now in the next video we'll be going to learn, this time we use the knowledge base, that is a static knowledge base. But suppose if we hit the some endpoint and dynamically, because this is a static data which we stored, but if we'll go to the some website, from there we'll get the data. In place of doing it statically, we'll go for the dynamic data and we'll pull it and we'll store that in our DB, and then we'll hit our endpoint and we can see the response. So in place of using the static data, we are going to use the dynamic data, and we'll see that in the next video. Thank you.